Hey folks, Chuck Black here. We are doing 52 weeks of Python and we are in week number 32. The topic for this week is nmap. Nmap is a package and utility that can be used to discover open ports on the network and to discover devices in the network. In this session, we will be looking at nmap. We will see that nmap is used by quaca to do port scanning. You will also be looking at code that, as you can see here, discovers devices in the network using ICMP. It discovers open ports on multiple devices in the network. We'll be looking at code that exercises nmap functionality, and you will hear me talking about how I kind of like nmap and am considering utilizing it for discovery functionality inside quaca. So that's what we'll be talking about. Hopefully that will be of interest to you. So let's get started talking about nmap. Okay, so let's get started talking about nmap. As you know, we're in this module M04 networking. We've talked about netmiko, we talked about napalm, we talked about SCAPI, now we're talking about nmap. Now nmap and SCAPI have a lot of the same or similar types of functionality, so you'll see similarities when we go through what one does over the other. I'm not in a position to recommend one over the other. I will tell you that I've discovered some nmap stuff that actually is pretty nice, that makes me think about how I might want to change some of the quaca stuff that we do. Right now we use nmap only for doing extended port scans, but there's a nice discovery capability that I actually put into this nmap example code, and you'll see that in just a moment. Now, going over here, as long as we're in the browser, if you want to learn more about nmap, then you can go to nmap.org. I am at nmap.org/book looking at manual pages, and you can see there's a large amount of documentation that is available. There's, of course, an introduction, there's a reference guide, which is where we are right now. Inside here, you can find the description, which is right down here. It talks about how nmap stands for Network Mapper, open source tool, network exploration and security auditing, yada, yada, yada. So this will tell you a lot about it. It will also give you a lot of the details. There are many, many, many different options that you can use for scanning both hosts and individual hosts ports on specific hosts, and so we're only going to do a small sampling of that, but you can come to this page and learn more about it. It does a good job of not only describing the options but also telling you what it does and how it does it. So I would probably recommend that if you're interested. So let's get started looking at the code. Okay, so let's talk about using nmap in the examples. Now, before we do that, I want to direct you to what you need to do in order to install nmap. Now, you probably, by this point in time, will have installed things to allow you to do netmiko, napalm, SCAPI, etc. But there's something important that I want you to be aware of when it comes to installation of nmap. So I've gone to this is my GitHub page for quaca in the wiki, and I clicked on quaca VM installed software. So this is what I use for quaca. As you know, I've mentioned that I'm using nmap for some of that, but this is helpful to us as well. It just happens to be true. So let's look at the first thing that you need to do. The first thing that you need to do is you need to, on your Ubuntu system, I don't know exactly what it is, you can look up the nmap information for your particular distribution of Linux or your other operating system. You would, on Ubuntu, you would do sudo apt-get install nmap, and here's the kicker: pay careful attention, don't fall asleep during this one. For doing the Python installation, doing pip3 or whatever version of pip you're using, however you use pip, you need to be installing, look at this right here, it's Python nmap. There is a package called nmap, and if you install it, things will not run as you want them to run. So you need to because that's the wrong nmap. So you need to do Python nmap and follow this. Now, if you have other distributions of Linux, or if you have another operating system. I'm here on the installation page this is actually for Linux, but I went to this install guide. If you do go to the install guide, then you can find the different Linux installations, Windows, Apple, etc. So just want to make sure, what did I tell you about? I told you about this, and that is that when you install for your Python package, you need to install Python-nmap. That's what you need to be doing. Okay, let's get started looking at this. The first thing that you'll need to do, of course, is to import nmap in order to use it. So we're going to do that. Now, what you'll be doing is you'll be using this thing called a port scanner typically. Now, I use port scanner here, and then later on I actually use port scanner async, but that is basically what you will be doing, and you'll end up with an object, and from that object then you can then do scans. So let's take a high-level overview of what this nmap example does. The first piece of it is in this while true loop. It's going to sit here, and it is going to ask you to enter an IP address, and based on that IP address, it's going to go and scan the ports of that device. Now, the next thing that it's going to do is it's going to go through a sequence of scans that are intended to discover hosts or hosts with open ports in the network. And so that's what I'm going to be talking about second. So let's dive into the first part of this. So let's look at this first section. So we're doing while true. We're using the input statement to allow the user to input an IP address for a host to scan. And if you hit return, then it will jump out of this loop and go to the next stuff. Once you've typed that in, what it's going to then do is it's going to use this nm object that we just created right here. It's a port scanner, and we're going to direct it to do a scan. And there are a boatload of different parameters that you can pass in. You can do this in many, many different ways. Once again, I will direct you towards the reference pages that are available here in the reference guide. There are tons of things that you can do, and those are very useful and very interesting. I'm just doing a subset of stuff. And so what am I doing? What am I scanning? Well, the first parameter that I'm passing in is going to be the IP address that we just entered. The next parameter is going to be the ports to scan. So you can have a single port, you can have a list of ports, or you can have a range of ports. And in our situation, we've passed in a range of ports. Now, don't confuse this with the Python range built-in function that we use to do for loops. When I say range, this is just how it is referred to in terms of how the nmap people have defined this. So with a dash, and it's pretty common if you do use a dash, then that's going to indicate that there's a range there. But this thing right here, is that a special Python thing? No, it's just a string. And the string says 22 to 1024. Arguments, this is where you're going to find most of the things that you can play around with. And so what I'm doing is I'm doing this minus S of capital S, minus S of capital U, minus O, and I'm specifying host time of 600. Now, I got to admit, at this point in time, I can't even remember what the host time is. Perhaps that's a timeout, I'm assuming, but let me go through what these are. And if you want to know, you can go to the reference guide, and here's my reference guide, and I believe in port scanning techniques, it talks about a number of these. Yeah, so you can come through and you can see that there are many, many of these different things. So what we are specifying is we are doing a TCP SYN scan. So this will describe what it does, but basically it's attempting to send a SYN packet and seeing if it is going to get a reply from that. And that is, it's the most typical one, and the most basic one is where it tries to open a TCP connection. This is a little bit more clandestine way of scanning to see if that port might be attackable. And so I'm doing this, the dash S with a capital U is a UDP set of scans, so it's going to be doing UDP scans. The -O is not on this page here, but if we go back, I believe that there is OS detection. And so if you do -O, then it will give you some of the nice stuff that you may remember from Quaca. Here it tries to figure out OS match. Wasn't able to do an OS match on that particular device that I did. If I did it on a Windows device, it would come back with Windows stuff. In fact, while this is going on, why don't I choose my laptop on which all of this is running, and I will do an extended port scan, and we'll get that going. So that is what I'm doing here. This has to run in super user mode, and consequently I can't run it in the debugger. I have to run it outside in command line, so I can do sudo whatever and it will run it appropriately. And what I do is I print out the command line. Remember, this is our F string. I can use this nm thing that's my port scanner and call into this method called command line, and it will tell me the entire command line. And then what I do first is I print out the output. So let's look at our output here just so I can tell you. So here's the OS information. It tried to match the OS, and it says that there's an 87% accuracy that it's Microsoft Windows XP S2, 85% accuracy that it's Windows 7, 85% accuracy it's Microsoft Windows Server. I can tell you that I'm running Windows 10. I'm not running any of these actually, so I don't know what it does and how correct this is, but it's doing its best guess. Obviously, it's got this accuracy percentage. This is what it thinks that it is. Anyway, that's kind of what that -O does for you. So let me do this. We're actually going to run this, and then I'm going to describe this in just a minute. Let me go and run this. So let's go ahead and run this. As I mentioned, we need to be running it from a terminal window so that I can run as root. And so that is what I'm doing right here. I'm going to hit enter. Now it's asking me for an IP address to scan now. I know that 192.168.254.14 on my network is my little laptop on which all of this stuff is running. So it's going out and doing that, and as you saw, it is actually going to be looking at every single one of these ports. Now you can just have ports that are of interest to you, as I mentioned, and things will go much quicker, but it's having to experiment with trying to establish this TCP connection on every port, and so that is what you're seeing right there. And let's see how we are doing. So it has completed. Here is the command that it gave, just so you know, and I didn't mention this, but you can run nmap from the command line. In fact, if you do sudo apt get install of nmap, then you can run it. You don't obviously need any of the Python pip stuff in order to do just nmap from the command line. And when you exercise it from here, what it's really doing underneath the covers is it's going out and it's running the actual nmap functionality as it's doing here. And here's the scan output. This may look familiar to you. What you see here, if I were to go over back to what I have here, you'll see that this is going to be pretty much exactly the same because we're doing a scan of the same item. So here's the information that it prints out. Some interesting stuff here would be the port scan, and it's telling me that for TCP, port 135, 139, 445 are open, and it was able to connect to those or get a response from those. And in the UDP world, port 137, now I can tell you from experience that these are all Microsoft NetBIOS-y type of ports that Microsoft uses to communicate with the rest of the world. And in fact, it actually gives you a little bit of net bias information there. Microsoft DS, I'm not sure what DS stands for, but here's the UDP net bias port as well, and 135 MSRPC. So that's Microsoft RPC communication. So that is that response. Now here you see little bits of information that you don't see in my output of Quaca. What is going on with all of that stuff? Well, that's the next code, and we're going to look at that right here. The next thing we're going to do, we're not actually doing another scan, we're just going to print some stuff out. And I did this a while ago, and I left it in, even though there's something that I don't understand entirely about this. So I understand that we're going to be calling this method all TCP, and that basically gives me a list of all ports that are in the TCP realm that are open, and that matches what we see right here. 135, 139, 445, those are all TCP ports, and as you won't be surprised, UDP 137, that shows up right there, and there are no IP ports that it was able to determine are available. How did I get those? Well, I called all TCP and it printed them out for me, printed out the list, all UDP, all IP. That's all fine and good. If I did search a particular device and it didn't have any of these, or it didn't provide a list, then it would, if my scan failed in some way, and there are some devices for which I end up with nothing that matches this IP address here, then I get a key error and I print that out. Now, the one thing that you may be thinking about, and that I just started to think about this morning, and I spent a small amount of time trying to figure it out, maybe 20 minutes, looking actually at the nmap code itself. So I actually went down into nmap. This is the nmap that's installed on my system, and began to look so that I could understand this. This is not something that I've done. Now, I'm not a long in the tooth Python developer. I've spent most of my life developing in C, C++, and languages prior to that, as well as Java, Scala, more of those system programming languages such as that. And so Python, I am fairly new, so I'm not like Mr. Advanced. All of my knowledge of advanced programming stuff from other languages I'm aware of. But here's the thing that confused me, and I still haven't figured it out. So if you are an experienced developer and want to inform me in some manner, feel free to do so. But this is a class. The way that we reference things in a class typically, and if you're new, I don't want you to worry about this one iota. Do not even give a single thought to this. But the way that we reference things in a class, and we've seen this before, is we specify a dot and then either a method or a piece of data. And in my next, some point in time, I'm going to go into, and we're going to create a napalm. At least my plan is to create a napalm-like set of classes and objects that we can use. But when you have an object, you usually do dot and then you reference it somehow. Guess what? Doesn't this look strange? It looks like nm is actually a dictionary, because we're passing in this string IP address inside the square brackets, which is referencing a piece of data in a data structure. So it's treating nm as if it was a dictionary. I did a quick perusal of both the code and online, and I didn't find anything specific, but I wanted to record this particular lesson. So I'm going to go ahead and leave that as something that I don't entirely understand. I can tell you that there is this thing called a post scanner host dictionary, and if I do a Control F so I can find all the instances of that, I can find that it is actually a class that inherits from dictionary. Again, if you're new, don't worry too much about this, but if it inherits from dictionary, then it inherits many of the attributes, and if you have a class that is defined in this manner, you can refer to its data in traditional dictionary manner. And since, as we saw just a second ago up here, that some of these results, once there are results, that it is actually turning out to be this dictionary, and that the items in the dictionary, once you get down here, are actually the host names, which are going to be those IP addresses. Then I'm assuming that this is how that works. But I didn't want to delay doing our discussion of nmap because there's so much more to nmap, and this is just a tiny piece of it, so let's not worry about that. But I thought that I would mention that. Anyway, I can type in other things, and what I'm going to do now is I'm going to type in my gateway, 192.168.254.254. If I, whoops, like I said, 254. I'm still learning numerals. So there we go. I'm going to let it run. Now, this is the point in time where it's going to take the better part of 2 minutes to complete this scan. So I suspect that it finds different things, or maybe that the gateway is fighting back in some way, but this scan actually takes a very long time. And I suspect what I'm going to do when I actually do the post-production of this is I will either put a funny song over this that you can listen to in the background while you go and do something else, or I will just speed it up so we don't have to think about it. So I'm going to stop talking now, and I will let this run its course. Okay, well, that was a long wait for not a whole lot of information. This is just telling me that it didn't find any open ports, which is interesting because when I run my other test via quaca, I do get some open ports, so probably I'm not probing the right thing. The last thing that I'll point out to you is that I am doing something different in my scan on quaca, and we'll look at that. And so that may be an indication of why we didn't end up seeing anything in this case, but we did in the others. Okay, well, that's it for the port scanning of devices. Next, we'll move on to looking at discovering devices in the network, host in the network, or ports on hosts that are actually open in the network. Okay, so let's look at the code that uses nmap to do discovery. And in these situations, we're going to be scanning based on a particular port. At least the first couple are examples of doing that. So I'm using the same nm object that I used before. I created it up here from the port scanner, so I am using that. And I'm instructing it to do a scan. Instead of telling it to scan just for a single IP address, in this instance, I'm asking it to scan an entire range. So this is where I ask it to scan multiple hosts. And I'm passing in arguments. The arguments that I'm passing in indicate that I want it to do this discovery or to probe on port 22 and to check to see if the port is open. And as a result of doing that, the results are kept in this nm object. I'm then able to call the method all_hosts, and that will allow me to iterate through all of the hosts, and I print them out. The next example, I'm going to do the same thing, except I'm looking for port 80. So this is looking for devices that have the HTTP port open, and I'm doing exactly the same thing, nm.scan, and when I'm done, I do all hosts. Now the next one is not looking at a particular port, but it's doing something different. In fact, it's doing exactly or very similar to what I do in quaca, which is to ping devices in this IP address range, and it will ping them, and that is the argument that I'm passing in right here. It will ping them, and if it gets a response, then I will be able to determine if that is so. And so when I do all hosts, what this is going to do is it's going to give me a list of all of the hosts that I then iterate through and I print out. Now the last situation that you see here is exactly the same, but I'm doing it a little bit differently. In this situation, I first have created a new port scanner, but this is called port scanner async. That allows me to do things in an asynchronous manner. Make sure you do that. I didn't do this and found that it threw an exception, which is no big deal, but you just have to figure out or understand why. The difference is I'm going to be passing in this thing called callback. So I'm going to say callback equals, and this thing that I pass in right here is actually the function that I have defined right here. And it's going to give me two things. Number one is going to be the host that I discovered, and the second is going to be the scan result, so the little bit of information. And so basically, the working code is that I call this thing right here, and then make sure you do this. I didn't do this at first, and my program exited immediately. You need to wait until it's done scanning, and the way that you do that is you can do something like this, which is you're using your port scanner async object and saying while it's still scanning. So in other words, this will be true if it's still scanning. When it's done, it will become false and you'll be done. And I could have slept or done whatever. In my situation, I did what some of the examples said, which is apparently there's a wait function I can call. So this waits 5 seconds and then it goes back. So it basically sits here and continues to wait until it's all the way done. So let's look at the output of this. So let's look at what the code is and what it prints out. So this code says scanning all hosts in subnet using port 22. That's what you see right there. It's going to sit on this call, this nm.scan, until it's all the way done. And when it's done, I'm going to iterate through all the hosts that it discovered. And that's where I print this out. And here's my list. 142 and 26 seem to have port 22 open. The next thing I do is I'm looking for port 80. So I'm doing exactly the same thing. nm.scan is going to wait until it's done. And then I do nm.allhosts. And you can see 142, 154, 254, and 26 are all have port 80 open. And the next thing that I'm going to do is I'm doing this ICMP thing. And so you can see here is my, let's see if I can see all of them. Here's my list of all of the devices that it discovered. If that looks suspiciously like my quaca output that you see in the hosts, then that's exactly correct. Those are the same devices. Well, it's not. My quaca constantly goes out and does discovery over and over again every hour or something like that. So it's picking up devices like when my wife is here and her devices are here, etc. But this is the general idea. And the last one, remember, I did this thing down here where I called discovered host, and in that situation, I'm actually printing out. Let me move this so you can see it. I'm printing out the screen stats. That is this lower portion that you see right here. And I'm going to make it wider so you can see it a little bit better. Here you can see basically this should be almost exactly the same set of hosts as there were there. The only difference would be if something is no longer responding. But you see it's printing out this extra data. So the next thing I'll do is we'll watch it actually run. So here I am running the example. I'm hitting enter to not do the IP address scan, and I'm discovering devices that respond on port 22, and you can see those two devices had it open. For port 80, you can see I have those 4 devices that had ports open. Now, right at this point, it's actually doing discovery using ICMP ping. So it's going out to every device in the subnet and doing an ICMP echo request. And for those devices that respond, it's storing them up, and it will allow me to print them out as soon as it is all completed. And that's what you see right there. Now, what's already beginning to happen is the next discovery. In this situation, I'm doing exactly the same thing as I did before. In other words, I'm telling nmap to do an ICMP echo to every device in the subnet, and it is telling me when these devices reply via a callback, and I can check to see if it has been heard or not, if the response has been received, and if it has, I'm printing it out. And so basically the same thing is happening as what happened in the previous example, except this time as every response comes in, I'm actually printing it out. It actually takes a little bit longer to do it this way. So let's remind ourselves of how quaca uses nmap. As I mentioned, we don't use it for discovery. I'm contemplating doing an update to the way I do discovery to discover not only the devices that exist, but also to discover their nature in terms of the vendor, whether it's Windows or Mac or network device or something like that. So I may end up changing that. But for right now, all we use nmap for are for port scans. And so there's two types of port scans. For whatever reason, my mouse over text is really tiny, but that says scan for open ports. This one says extended scan for open ports. So this is a regular port scan that is done within the quaca server. This one right here, the extended port scan, is the one that requires root access, and it runs in an external remote worker. And so that is what we're talking about. If we look at the code here, under my workers, I have this thing called port scan thread. I'm looking at my port scan thread here, and in the code, which is when it runs and does what it's going to do, you'll look here and say, wow, this looks kind of familiar, and it should. Basically, all I do is I create a port scanner and call it nm, and then I do nm.scan, and I'm passing in the host IP address, which was passed to the worker. You can see that it was set right there. Actually, that's not where it's set. That's when I'm processing it and sending it back in. It's set at initialization, and this is when I set the host IP address. I set the port range, and I set the scan argument. Let's just go back down here and not get too distracted by myself. Here's my host IP. Here's my port range. And here are my arguments, same as the stuff that we talked about. So, you think about quaca being special. It really is doing exactly the same thing in many ways that we're talking about and that you're learning about in this class. So these are what I'm passing in. This is my port scanning mechanism in my remote worker. Then I just process it by calling in here. I have a function that I created called send port scan that's going to do an HTTP request, and it's going to send in this scan output. And the scan output is, just the stuff that was right here, the result of the scan. So that is what I do there. That is for the extended scan. The local scan is a little bit quicker. It is something that gets called from the view, and basically whenever we need to do it, we call in right here. We create a port scanner. I do a scan. I'm not passing in any arguments. That means it's going to do the default, and the default is to try to set up a TCP connection, which is not as internal and sneaky and all the other stuff as all the fancier nmap stuff does. And so I can do this. You'll notice when I try to get the output here, I'm really just seeing, okay, did this succeed? If I have nm with a key of my IP address, this is using this key that we talked about before. I haven't looked into that yet, but I will. But basically it's saying, is the key of this IP address present in this nm object? And if it is, then it sends back, hey, that's that all TCP thing that we looked at when we looked at my example code. So it's sending back just the TCP stuff because that's all it's doing is a TCP scan. So that is how quaca uses it. We've looked at it a little bit before. If I was to do this here, this is my regular scan. It's using this port scan code where I don't have to go anywhere do anything. You can see I did get a result, and my result was that no ports were open. I actually don't know what would happen if I do my TCP port scan on my local laptop. Hopefully that won't cause any problems. Yes, I remember this. My scan fails. So basically I tried to get some information, and for whatever reason, scanning the Windows host at this simplistic level did not work, and that's why things like this extended scan are possible. So my extended scan is going to be going out. It's going to be consulting. It's sending the request to the worker. The worker is going to do the more involved request with those scan arguments that we talked about. Once it gets the results, it's going to send it back to the quaca server, and then it eventually percolates its way back to the user interface. And here you can see the information that it got back. So it both is telling us about all the addresses it learned about, both physical address, the MAC address, as well as the IP address. It's telling me the host name. That's a handy thing to have. It's telling me this OS match information. It's telling me the port that it used to get some of the information. I don't know exactly what that means. It's telling me the reason that it thought that it was there. And it's telling me the ports that are open. So port in TCP land, port 135, 139, and 445 are open. And this didn't show me the UDP port that is open. Oh, you know what? I'm not looking for UDP here. In my code, in my nmap example code, I added not only looking for the TCP SYN, but also for doing UDP. Here I'm not doing UDP. And here it says the vendor is Intel Corporate, whatever that means. So I don't know if that is a good representation. I think I'd have to look at the OS and try to parse that to put something of interest in my output if I was to choose to do this. But that's what we get back from this port scan that we were looking at before. Notice the arguments as I have them right now are doing this TCP SYN test as well as vendor and operating system. And this host time, I did look up host time. That's basically saying I want you to just bail if you're not getting something back in 5 minutes. Probably what it means is that by the time you hit 5 minutes, whatever point you're in, just give me that amount of information. That's what host time means. Okay, that is the use of nmap, and I got to say, I kind of like it. I may be incorporating it into quaca. Hopefully this has been useful to you as well. So what do we learn in our discussion of nmap? Well, we discovered that it does have some good documentation. You can go here to nmap.org. There's actually something that they call a book, which is really a nice reference guide that describes a lot of the stuff that we talked about. Well, probably all of the stuff we talked about and more in this class. So there's a ton of stuff that you can get access to in here. We looked at some code. We had two major sections of code. One was doing port scanning for a single IP address, and we looked a little bit at all the different parameters that you can pass in. And I was reminded eventually that host time is the eventual timeout for slowly responding devices. We looked at getting the information back. We looked at creating the port scanner. We looked at how you actually can dereference to get the TCP ports that are open and UDP and IP ports that are open as well. We have some code here that allows you to type in an IP address and find that. Then we looked at discovery. In discovery, we used the same port scanner initially, and we went through and we checked to see which device is in the network. So we're passing in not just a single device, but a range of devices. And we said, okay, who has port 22 open? And we did the same thing with port 80. Then we did ICMP echo. So this is basically doing a similar thing to what I do in the discovery thread in quaca. And we printed them out, and we saw that you can also do that using an asynchronous version where you create a new port scanner, which is of type port scanner async, and you pass in a reference to your function that will get called to every host that it attempts to talk to. And as you can see here, I didn't go over this in the discussion, but I'm checking to see if the host is actually up. And if it is, then I say found host, and we print that out. Last thing we did was we looked at quaca and what quaca does. There's two types of scans with quaca. Remember, there's the normal port scan that is done within the quaca server. And then there's an extended port scan. This is an example of an extended port scan. The extended port scan actually uses the remote worker that runs the scan, exactly the same as what we did before. The arguments are a little bit different, but passing in a port range and a host IP address and then returning that information. The local little port scan just does nm.scan for an IP address, doesn't even pass in any parameters, and returns all the TCP ports that are open. So yeah, that's what we do with nmap. I tend to like it. It's got good documentation. It does a lot of functionality, so that's nice. And I may even consider using it in Quaca, modifying some of my existing discovery code to make use of nmap. Hope that this has been helpful to you in your Python endeavors in the future where you may be using nmap. Thanks for listening.